Hi everyone, it's me, Mr. D, and it's time again for what Mr. D Math Explains. We're going to do a deep dive into different topics in math and take a look at the way me, Mr. D, for Mr. D Math, looks at math, and now you can too. Let's go! In this video, we're going to look at prime factors, prime factorization. We're going to also look at what we call the greatest common factor and the least common multiple. Let's start with what we call the prime factorization. You've probably heard the word prime, like in prime factors, and it just means what? That the number can only be divided by 1 in itself, or the factors would be 1 and the number. That's it. That makes it a prime number. So when we do the factorization, what we're looking for is we're looking for all the factors, and a factor is a part of the number, something that can divide into it with no remainder. So when we talk about the factors of 1,800, let's start with some numbers we know. Think about this. Because it ends in 2 zeros, it says 1,800. Really? 1,800? Really? 18 times 100. That's 1,800. What do you know about 18? 18 is 9 times 2, but you could say 3 times 6, whatever you like, and 100 is 10 times 10, or if you want to use 50 times 2 or 25 times 4, they all end up taking you to the same place. Now what do we have? 9 is 3 times 3. 2 is already a prime number, so that stays the way it is. Then we have each 10, which is 2 times 5, and another 2 times 5. What do we have? I like to write them in order. We have 3 2s, 2 times 2 times 2. Then we have 2 3s times 3 times 3 times 5 times 5. That's what we call the prime factorization. Sometimes people will write this using exponents. So we would say 2 to the third power times 3 to the second power times 5 to the second power, and there's our prime factorization. That's it. But why do we use prime factorization? Well, I'm about to show you when it comes to working with greatest common factors and what? And least common multiples. Let's look and see what I mean by that. A greatest common factor, sometimes people call it the greatest common divisor. Think about what's happening. The greatest means what? The most, and when something's in common, it means the same. And then we say what? Most same factors. Think of it like that. And I'm going to show you some examples in just a moment. But what about the least common multiple? And sometimes we think of that as what? As a common denominator, but we always want the lowest common denominator. So we're talking about the least common multiple. So now we're looking for what? The smallest same. When we say multiple, I'm going to say it this way, like skip counting. Skip counting, what do I mean by skip counting? Well, think about the idea of skip counting by 4s. 4, 8, 12, 16. These are what we call the multiples of 4. I'm actually skip counting by what? By 4s. 4, 8, 12, 16, and ... You can keep going. So let's take a look at some examples with numbers in it. Let's see how you can do as well. So here we have the numbers 24 and 36, and we want to find both the greatest common factor and the least common multiple, but we can use the prime numbers to take us there. Let's start with 24. What multiplies and makes 24? Let's say it's 8 times 3. This is great. Why? Because I like the number 8. 8 is actually a perfect cube. It's 2 times 2 times 2. You might think of it as 2 times 4, which becomes 2 times 2 times 2. So when I say 8, you say 2 times 2 times 2. Practice it. 8, 2 times 2 times 2. There we go. And then 3 is already a prime number. It stays a 3. What about 36? Well, we have what? We have 6 times 6. Well, that's easy enough. 2 times 3 times 2 times 3, but I'm going to write it in order. 2 times 2 times 3 times 3. Notice that I'm not going to use exponents, and there's a reason for that. Why? Because when I'm finding the greatest common factor, I don't want exponents. I want to see the factors. What was the greatest common factor? The greatest common factor was the most same factors. What do they have in common? Well, do you notice that they both have 2 2s? And they both have 1 3. But one number has 3 2s, the other number has 2 3s. Well, we want the most same. So what do they have the most of? They have the most same in 2s. They have in common 2 2s. And in 3s, they have 1 3 in common. The greatest common factor, or some people call it the greatest common divisor, so they'll also say GCD, is going to be 12. That's it. But what about the least common multiple? The least common multiple now is saying the smallest, which is going to sound funny because the greatest common factor is a smaller number and the least common multiple is a bigger number. It's almost reversed. It's kind of funny how that sounds, but let's look and see what I mean by that. So to find the least common multiple, what is that going to be? Well, now I've got to be able to see both numbers at the same time in what? in my factors. So what do I need this time? I need them to look like each other. Think of that. I'm going to write that down. Make the numbers look like each other. Look like each other? What do I mean by that? Well, do you notice that this number has 3 2's, but this number only has 2 2's? To make them look the same, this number would need another 2. Now, I would look over here and say, but this 136 has 2 3's, but 24 only has 1 3, so it needs another 3. We're going to be putting these numbers on. Now, we don't have 24 and 36 anymore. Why not? Because we have a new number, which is the least common multiple. What was it? Well, to get them to both be the same, we need now 2 times 2 times 2 times 3 times 3. Look what you see. 2 times 2 times 2 times 3 times 3. This is 2 times 2 times 2 times 3 times 3. Well, wait, we did it. We found the least common multiple. 2 times 2 times 2, well, you already know that's 8. 3 times 3 is 9. Well, there it is. It's 72. Just like that, we found what? We found the least common multiple. Make the numbers look like each other. That's all there is to do. But what if they don't have something in common? What do we do then? Well, let's find out. Let's look at the next example. Here we're going to take a look at 27 and 8. 8, there I did it again. 8 is what? You know, it's 2 times 2 times 2. That's all done. What about 27? It's 9 times 3, which we would say is what? 3 times 3 times 3. So now what do you notice? The greatest common factor or the greatest common divisor, what do they have in common? Well, you could say nothing, but they do have something in common. Why do they have something in common? Because think about my 3's and 2's as prime numbers. You know, writing them down, the prime factor is 3, but the factors of 3 really would be 3 times 1. So does it make sense to say that I could put a 1 in front of this and it's still 27? 1 times 3 times 3 times 3. 1 times 2 times 2 times 2. Well, how about that? They do have something in common. What do they have in common? They have a 1 in common. The greatest common factor or the greatest common divisor would be 1. Well, that's easy enough. But what about the least common multiple? The least common multiple, I need to make sure that they do what? They look like each other. Well, I have 3 3's over here, but I don't have any 3's. So this one's going to need 3 3's. Now they look the same, but it's not an 8 anymore. What about the 3 times 3 times 3? There's 27. It's not going to be a 27 anymore. Why? Because it needs 3 2's. Oh, look at that. What did we really do? Well, we just really multiplied them together. 27 times 8. 3 times 3 times 3 times 2 times 2 times 2. And if you multiply those together, you'll get 216. And there it is, the least common multiple. But what happens when the numbers are bigger? What are you going to do then? Well, no problem. Why? Because we already know what we're doing. Let's take a look at what I mean. What do we have this time? Well, this time we have 120. But notice that 0 at the end. That's a 10, which means what? It's 12 times 10. Oh, how about that? How about 180? Same thing. It's a 10. It's 18 times 10. You already noticed they have some things in common. But let's keep going. 12 is 4 times 3, and we know 10 is 2 times 5. Our 4 is 2 times 2. We have 2 times 2 times 3 times 2 times 5. Let's write them in order. 2 times 2 times 2, there's that 8 again, times 3 times 5. How about 18 times 10? 3 times 6 is 18. Last time I used 2 times 9. It doesn't matter. You can put them in any order you want. Then we have what? 3 times 2 times 3 times 2 times 5. What do we have when we write them in order? 2 times 2 times 3 times 3 times 5. Let's get to it. What do we need? The greatest common factor. The greatest common factor, well, we need to see how many 2's do they have in common. Well, what do you notice? They have 2 2's in common. Well, there we go. That's part of it. Do they have any 3's in common? They do. They have 1 3 in common. How about 5's? Do they have any 5's in common? Well, they both have a 5, so we're going to need a 5. That's what they have in common. The greatest common factor, or what we call the greatest common divisor. Let's see what we have. Well, we're going to have what? 2 times 2 times 3, 4 times 3 is 12, and 12 times 5 is 60. Well, that's it. We already found what? We found the greatest common factor. Now we need to find the least common multiple. How are we going to do that? We need to make them look like each other. What do we see? Let's start with the 2's. There's 3 2's over here, but there's only 2 2's here. This one's going to need another 2. It's not going to be 180 anymore. How about 3's? We have 1 3 here, but 2 3's here. This one's going to need another 3. It's not going to be 120 anymore. Notice that we have 1 5 and we have 1 5. That's already the same. So did you notice what we needed was the first number, 120, needed a 3. The second number, 180, needed a 2, so they could look like each other. Well, that wasn't so bad, was it? What do we have now? Well, we have 2 times 2 times 2. We have the 3 2's. Now we have 2 3's. and we have a 5. There it is. Now you could say what? What did we notice that we just did? We took the number 120 as it started out and we multiplied it by 3. If you know 3 times 12 is 36, then 3 times 120 is 360. But what about over here? Does the same thing work? Well, sure. We had what? We had 180 with the factors 2 times 2 times 3 times 3 times 5, and we multiplied it by 2. Oh, yeah. 2 times 18 is 36. Well, then 2 times 180 is 360. That's it. That's what it's like to work with greatest common factors and least common multiples. There's more to come, of course. Why? Because when we're doing math with Mr. D, that's when kids say, what? I finally get it. And by the way, when I say a kid could be somebody like me, even an old guy. I'm still a kid too. So maybe you're a high school student, maybe you're a college student. Either way, we're all the same. We're all kids. And so this is when kids finally get it. See you next time.